Okay, guys, today we're going to talk about your 4.7 discriminant notes, and we'll talk about the vocabulary as to what that is and kind of what the expectation is with what you know about it. So first and foremost, we are not focusing on the quadratic formula in this class, but in order to make sense of the discriminant, we do need to at least just kind of have a loose introduction to it. So in this class, if ever you're wanting to know the x-intercepts or the horizontal intercepts, you're just going to use Desmos and you're going to touch and see where the x-intercepts are, and that's it. Or if you're in a TI, you can, put your formula in y equals and then just intersect it with the 0 line. And once again, just intersect method to figure those out. However, if you didn't have graphing technology, there is a way to find the horizontal intercepts with a pencil, and that is called the quadratic formula. And that formula is this beast right here, the opposite of b plus or minus the square root of, oops, that's supposed to be a b. Let's see if I can fix that. There we go. B squared minus 4ac, all divided by 2a. So again, not the focus of this class, but if you had to find the x-intercepts with a pencil, you could use that formula. So if you look at number 1 on your discriminant document, the a value of number 1 is the number in front of x squared, so that's just 1. The b value from number 1 is -8, and the c value from number 1 is -20. And if you plug all of that into the quadratic formula, it would look like this. So first of all, this right here is the opposite of the b value. So since our b value is already -8, sorry, that means we'd be taking the opposite of -8, that's going to turn into a positive, plus or minus the square root of -8 squared minus the number 4 times a, which is 1, times c, which is -20. Ooh, I ran out of room there. That's -20. And then all of that gets divided by 2a, so 2 times 1. Okay, so that's just putting all the elements in there. Now, most importantly, what this all comes down to is whatever the inside of this part of the formula comes out to be, we need to know what that is. So if you separately go to your calculator and just type in -8 in parentheses, -8 squared minus 4 times 1 times -20, you should get 144. Should. So go ahead and practice typing that, see how you do, but you should get 144, which means the next line of our work, so this double negative right here, that's going to turn into just a regular 8 plus or minus the square root of 144, and then all divided by 2 times 1, which is 2. Okay, so once you have it that far, this is now when the quadratic formula gets simplified if possible, and then you can solve it after that. So first of all, as far as simplifying it goes, the square root of 144 is 12. If you type that into your calculator, you'll get 12. So what this formula turns into next, I'm going to take it up here now. Oops. There we go. Take it up here. So if you type this in, or not type this in, but if you simplify the square root of 144, you get 12. So it's 8 plus or minus 12 divided by 2. And now, since the square root of 144 simplifies to 12, this is where you can break it apart now and get the two answers, the two x-intercepts. So you have 8 plus 12 divided by 2, but also 8 minus 12 divided by 2. And so 8 plus 12, that's 20. 20 divided by 2 is 10. 8 minus 12, that's -4. -4 divided by 2 is -2. So the two x-intercepts on that quadratic are at positive 10 and negative 2. So let me switch this now. Or no, I'm not going to switch it yet. I'm just going to go through the next two problems actually and just briefly touch base on what those would look like. So let me erase all this. And I'm now just going to go to your document and I'm going to briefly, because again, guys, the quadratic formula is not really the point right now. I do want you to see it. I want you to be familiar with it, but you're not going to be asked to use the quadratic formula. So don't stress about that part. But for number 2 on your document, the A value is 1 again. The B value for number 2 is 10. And the C value for number 2 is 25. Okay, so if we put all this in the quadratic formula, so the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. Okay, so there's all the components. You would type all this inside stuff in first. So grab a calculator and just figure out what's 10 squared minus 4 times 1 times 25. And guys, this time you should get 0. 10 squared minus 4 times 1 times 25 is 0. So on this particular one, the square root of 0, well, is 0. So negative 10 plus or minus 0 divided by 2. Negative 10 plus 0, plus 0, and then also negative 10 minus 0. Okay, but check it out. Negative 10 plus 0, that's negative 10. Negative 10 minus 0, that's still negative 10. So both of these answers, when you simplify them, you just get negative 10 divided by 2, which is negative 5. So notice on this one, unlike the first example, I'm not getting 2 answers, I'm only getting 1 answer. And the answer is negative 5. Now the last one on your discriminant document, number 3, the A, B, and C value for number 3. There we go. Okay. So for number 3, the A value on number 3 is 1 again. The B value is negative 2, and the C value is 10. Okay, so quadratic formula, once again, not the emphasis, but I do want you to see it. So the formula would say the opposite of B, so the opposite of negative 2 plus or minus the square root of, in parentheses, negative 2 squared minus 4 times A, which is 1, times C, which is 10, all over 2A. Okay, so on this one, when you type in parentheses, negative 2 squared minus 4 times 1 times 10, you should get negative 36. Square root of negative 36. Oops, that's supposed to say 2 times 1 up here. Right here. Oops. 2A should say 2 times 1. Okay. So in parentheses, negative 2 squared minus 4 times 1 times 10. If you type that in, you should get negative 36. Well, here's the thing. Go ahead in your calculator. Try to type in the square root of negative 36. You should get an error message. It is not possible. There is no such thing. And the reason why there's no such thing is because if you think about it, the square root of any number is supposed to be a number such that when you times it by itself, you get that answer. So like for instance, 6 squared is 36. That's why the square root of 36 is 36. And even negative 6 squared is also 36. Negative 6 times negative 6 is positive 36. the only way that you could potentially get negative 36 out of that is if you were to have a positive 6 times a negative 6. But ladies and gentlemen, by definition of square root, you can't have a 6 times a negative 6. It has to be a number times itself. So that is not a valid option. There is no number times itself that would make negative 36. This is simply not possible. Not in the real number system anyways. It is possible in the imaginary number system, but we aren't going to go there. So for our purposes, it's not possible. So what does that mean? Okay, let me switch now to a different image. And that is the graph. So you'll notice on your discriminant activity, I ask you to graph them in the middle section. So on the graph, the red, on my screen, the red one is number 1. The blue one is number 2 on my screen. And on my screen, the green one is number 3. So here's the observations that we need to make. Remember how the answer to number 1 was both positive 10 and negative 2? Well, check it out. Graphically speaking, right here, positive 10, that's at negative 2. There were absolutely 2 x-intercepts in that problem. Now, if you recall from number 2, there was only one answer, and the one answer happened to be negative 5. So look at the blue parabola. Lo and behold, right there. Yep, that parabola only has one x-intercept. One answer, one x-intercept at negative 5. Now you'll notice by looking at the blue graph that the only way that happens is if the vertex happens to also be the x-intercept. That is a rare case, but it can definitely happen, as you see in number 2. Now, number 3, on the other hand, if you recall, in our algebra, there was no solution. It's not possible. So check it out. Number 3's graph does not touch the x-axis, ever. There is no place where that green parabola touches, crosses, bounces, nothing on the x-axis. And so that is why when you tried to solve it algebraically using the quadratic formula, it doesn't work. It's not possible because there is no answer. So when you think about what the quadratic formula is trying to do, it makes sense how sometimes you get 2 answers, like in number 1's case, sometimes you only get 1 answer, like in number 2's case, and sometimes you get none at all. So now if we go back to our whiteboard here, so the thing about discriminant that you kind of need to know moving forward is just, first of all, the word discriminant simply refers to discriminant. Oops. Okay, just bear with me. I'm writing with my fingers here. So the discriminant in general just refers to this element of the quadratic formula. It's all that stuff that goes underneath the root symbol. Whatever that number comes out to be, we call that number your discriminant. So why does that number get its own vocab word? Well, it's because like you saw in numbers 1, 2, and 3, depending on what that number is, it totally dictates how many answers you're going to get. So if you have a positive discriminant, like you did in number 1, that is when you have 2 very distinct x-intercepts because the parabola crosses the x-axis twice. So you get 2 distinct answers, like in number 1, because you have 2 distinct x-intercepts when you look at the graph. Now, as you saw, that doesn't always happen. Sometimes your discriminant is not positive, but it's 0. like in number 2, the discriminant, this number, that number was a big fat 0. And so as you saw, when that happens, you only get one answer. And the reason why you only get one answer is because that parabola only touches the x-axis one time. So if your square root number is a 0, then you'll have a case like number 2, where the parabola only touches the x-axis one time because there's only one answer. And then the last instance, like you saw, oops, in number 3, was when that number underneath the radical was actually a negative. And if that number is a negative, well, as you saw, you cannot square root a negative number and get an answer, not a real answer anyways. And so as far as the algebra is concerned, there are no solutions to that. And if that feels alarming, well, you saw in the graph, it's actually totally possible. And that's because the parabola has no x-intercepts. So in that case, you just have an example like you saw in number 3, where you've got a parabola and it doesn't touch the x-axis ever. And that could happen if it's upside down too. If you think about it, it could just be maybe down here somewhere. So there's definitely cases when your discriminant or that number inside of the radical is negative, and in that event, you just have one of these cases where there's no answers because there's no x-intercepts. So that's the main takeaway message from discriminant. Again, you're not going to be asked to use the quadratic formula really ever in my class, but I do want you to understand that because of what's happening in the algebra, you sometimes get 2 answers, sometimes get 1, sometimes you get none, and all of that just correlates back to what the graph is doing with its horizontal intercepts. Okay, awesome. Thanks, guys.